Hi everybody, so today we're going to be doing notes on solving rational expressions. Remember when I do the RAT''L, that's my abbreviation for the word rational. So you can write out the full word if you prefer. Go ahead and pause this and write down the steps. All right, so step one, find the LCD. What does LCD stand for again? If you said least common denominator, you are correct. Least common denominator. So we are looking for the smallest thing that all of these denominators have in common so that we can simplify it. Step two, multiply both sides of the equation by the LCD, and this is what will eliminate our fractions to make it so that we can actually solve this thing like an equation that we're used to looking at and solving. Then step three is to solve for the variable. And then step four, this isn't for all cases. This is only when your original equation has a variable. I just realized I forgot to put in the denominator. So when it has a variable in the denominator, so basically when your original equation has a letter in the bottom of your fraction, check for extraneous solutions. Do you remember what extraneous solutions means? All right, so extraneous solutions is basically just a really fancy way of saying it looks like an answer, but it doesn't work when you plug it back in. So I'm going to say your answer doesn't work when you plug it back in. Can anyone take any guesses of when it wouldn't work if we have a variable in the denominator? When would it not work? If you said when your denominator is equal to 0, you are correct. So basically what we're checking for here with the extraneous solutions is when you plug this thing back in that we get as an answer, that looks like an answer, but if we plug it back in and we end up getting 0 on the bottom of a fraction, that means it's an extraneous solution and it doesn't actually work. So that's what we'll be checking for with some of these problems. Let's look at some examples now. So the first one we're going to do does not have any variables in the denominator, so we're just going to do steps 1 through 3. So first thing that we need to do is find our least common denominator. So what we're working with right now is a 4 and a 3. What is the LCD going to be? If you said 12, you are correct. So my LCD is 12. Now you have an option here with however you personally prefer to write this. When you multiply both sides by 12, some people, myself included, I prefer to just write it as one big old fraction. Some people like to put another parentheses, so they put the left side. I'll show you my hands. So they put the left side in parentheses and multiply that by 12. And then they put the right side in parentheses and multiply that side by 12. It's just personal preference. I'll ask you which one you prefer, and then I'll do that going forward. I prefer to write it like this just because it's less writing, but it's totally up to you. But for this one, just to make sure that you see what we're multiplying everything by and making sure that we don't miss everything, I'm going to show you exactly what we're doing. So we are going to have 12 times this first fraction, the x minus 4 over 4, plus 12 times the second fraction, x over 3, equals 12 times 6. If you feel more comfortable writing out all of this, you can continue doing that. I just want to show you this in the notes so you understand exactly what I'm doing and why stuff gets canceled out. So for the first one, 12 times my denominator of 4, that's going to simplify to 3. And then 12 times, or basically divided by 3, is going to simplify to 4. So my fractions are going to get canceled out. So if this one gives me 3, I'm going to have 3 and then parentheses x minus 4, and then plus 4, and all that's left in here now is the x, equals 12 times 6. And you could have just written 72 there if you want. So now we need to distribute this 3. So we're going to have 3x minus 12, and then 4 times x is 4x, equals 72. And now we're going to simplify and combine like terms. So what is the left side going to become? If you said 7x minus 12, you are correct. Equals 72. And then add 12 to both sides. I'm only going to show this part for this problem, just to give you a refresher on solving. So 7x equals 84. And then divide both sides by 7. So x equals 12. Do I need to check for extraneous solutions on this problem? You should have said no, we do not, because our original problem does not have any variables in the denominator. So no matter what, when I plug 12 back in, I know it's going to work because I'm not going to have 0 on the bottom of any of my fractions. So I'm fine. I do not need to check for extraneous solutions. So there we go. That's our answer. Let's look at another example. So example B. First thing we need to do is determine our LCD. So the denominators I have now are 2x and x plus 1. What do you think the LCD will be? If you said 2x times x plus 1, you are correct. That's going to take care of everything. And now we're going to multiply both sides of this fraction by that LCD. So again, I do mine all as one big giant parentheses. You can do yours as separate. And for the notes, I'm going to write out this next step. It is actually pretty helpful to write this. Maybe not with all the color coding, but know that you may not need the color coding. I personally like to do it just because it helps me keep track of stuff and helps you see, looking back at the notes too, where stuff comes from and why. So I'm just writing out my LCD multiplied by each individual part of this original problem. So that it makes it a little easier for me to see what's going to get canceled out. All right, so with this first one, we're going to have this whole thing divided by 2x. So the 2x's cancel. The second one, I have this whole thing divided by x plus 1. So the x plus 1's cancel. So when we simplify this, it's going to be x plus 1 times 3, the first term. And then minus, I'm just going to keep everything in parentheses to keep it organized. So 2x times 2x equals 2x times x plus 1 times negative 2. Now in terms of simplifying this, you can either distribute the x and the 1 to the 3, or I just do it this way. I go backwards and distribute. Oops. I'm going to have 3x plus 3, and then this gives me negative 4x squared equals, now for here, you can either choose to distribute the 2x and then multiply it by negative 2, or distribute the negative 2 and then multiply it by 2x. What I'm going to choose to do is multiply the 2x times negative 2 and put negative 4x times x plus 1 and then distribute, because then I only have to distribute once. All right. Actually, let me go ahead and rewrite the left side. No, never mind. I'm just going to leave it. 3x plus 3 minus 4x squared equals negative 4x squared minus 4x. Now, when we want to combine our like terms, this one actually works out really nicely where our x squared terms actually cancel each other out. So if you were to add 4x squared to both sides, they cancel, they go away. It zeroes out. So we're left with just 3x plus 3 equals negative 4x. So I want you to go ahead and push pause, finish solving this for x, and then push play. Go ahead and check your work. You should have gotten negative 3 over 7. I chose to just collect all of my x's on the right-hand side because it was already over there by itself, and then divide both sides by negative 7. Now for this one, do we need to check for extraneous solutions? You should have said yes, we do, because we do have variables in our denominator. So let's go ahead and do that. I'm just going to do the little check over here on the side. And it can be something super informal. You don't actually need to finish solving it all the way through. You just need to make sure your denominators are not 0. So you're going to have 3 divided by 2 times negative 3 over 7 minus 2 times negative 3 over 7 divided by negative 3 over 7 plus 1 equals negative 2. This denominator will not equal 0. This denominator also will not equal 0. You're done. You don't actually need to finish solving that. Just as long as you can confidently say, and if I ask you to check for extraneous solutions on your work, you do not need to solve this all the way through. You can if you want, but you don't have to. This I consider a sufficient amount of work because this shows me that you understand that's the reason why you're checking for extraneous solutions. So get another example. This one is a little bit more challenging because all 3 things are a fraction now. So you need to account for all 3 of those when you are finding your LCD. So what do you think the LCD will be for this problem? If you said 4x times x minus 1, you are correct. That accounts for the x minus 1, and the 4. Takes care of all 3. So I'm going to multiply this entire thing by 4x times x minus 1. And we're going to write the next step out together, and then you're going to try simplifying this on your own. All right, so we're going to have the 4x times x minus 1 times 6 over x minus, my LCD again, 4x, x minus 1 times my second fraction equals LCD times 1/4. All right, now I want you to try the next step on your own. You are just canceling out stuff that you can from your denominators and rewriting the next step. So go ahead and push pause, and then when you're ready to check, push play. All right, go ahead and check, see if that's what you got. Now we need to distribute. So a couple of options here. The last one's pretty straightforward. You just distribute the x because that 1, that's like saying that. You don't actually need the 1 written there. This one I'm going to choose to do all at one time. So I'm going to have 4 times 6, which is 24. And then 24 times x will be 24x. And then 24 times negative 1 will be negative 24. If you want to do that as 2 separate steps, totally fine. And then minus 36x equals x squared minus x. Go ahead and simplify this and get all of your variables on the left-hand side, and then push play when you're ready to check. All right, if you got all of your variables on the left-hand side, this is what it should look like. Now, you have a couple options here. Option number 1, you can factor out the GCF of negative 1. So you can factor out that negative 1 and then leave it written with the negative 1 out in front. Or option number 2, because this is equal to 0, we can essentially divide both sides by negative 1. And the right side will still say 0, but then it's going to flip the sign of everything over here. That's what I personally would choose to do, because it's cleaner, it's less writing, then I don't have to deal with the GCF out in front, and my answer is still equivalent. So all I did, this was basically, I'll write a little note. I'll do this in green. Divide both sides by -1. So now your leading coefficient, that x squared term, is positive, and we can use the big X to factor this. So go ahead and factor this, and then push play when you're ready to check. That's what you should have gotten. Now from here, we need to solve for x. So this is called the zero product property, which is review. You may not remember the name of it, but basically it means if you have stuff multiplied equal to 0, then that means that either the x plus 8 equals 0 or the x plus 3 equals 0. Or in other words, solve both of those for x. X equals -8 or x equals -3. Solve them both for x. Do we need to check for extraneous solutions on this one? You should have said yes. We have x's in our denominator, which means we need to check. So I'm just going to do that over here. And I need to check both of these. So I'm going to show my work separately for both. I'm going to do the -8 first. So when x equals -8, I'm going to have 6 over -8 minus 9 over -8 minus 1 equals 1/4. Will either of our denominators equal 0? Oops, sorry, scoot that over. No, neither of our denominators will equal 0. I'm going to go ahead and finish simplifying this one all the way through just to show you, if you choose to solve it all the way, what it's going to look like. So let's see, I'll go ahead and simplify that. So 6 over -8 is -3 over 4. And then -8 minus 1 is -9. So minus 9 over -9 equals 1/4. So -3 over 4 plus 1 equals 1/4. That's a true statement. -3/4, this is like adding 4 over 4. It's positive 1/4. So it works. And then we also need to check -3. So 6 over -3 minus 9 over -3 minus 1 equals 1/4. If you were to finish simplifying that, it would be -2 plus 9 over 4 equals 1/4, which if you were to finish simplifying that, that is also true. So both of these work. So we do not have any extraneous solutions. They are both possible answers. Last example of the day. First thing we need to do is find our LCD. But first, before that, you should notice, do any of our denominators factor? You should have said, yeah. This one is a difference of squares. This factors as m plus 1 times m minus 1. What is our LCD? If you said m plus 1 times m minus 1, you are correct. Now, some of you may be wondering, what if you didn't notice that this factored and you said your LCD was m minus 1 times m squared minus 1? Can you still solve it? The answer is yes. However, because your LCD is now a higher degree, that means the answer that you get once you solve this thing through is also going to be a higher degree, which means you're going to have a higher power that you have to simplify or factor. Making sure that you have the least common denominator, the true LCD, is going to keep all of your numbers as small as possible. All right, so we need to multiply this by our LCD. Go ahead and do that step and then push play when you're ready to check. Go ahead and check. This is what you should have. So a whole bunch of stuff cancels out. So now from here, I want you to finish simplifying this. Multiply and FOIL your stuff that you need to. Get all the way down to your trinomial, and then factor it using the big X. And then push play when you're ready to check. Go ahead and check your work. Now next up, do we need to check for extraneous solutions? You should have said yes, we do. So let's go ahead and do that. So first I'm going to do m equals -4. So if I plug in -4, I'm going to have 2 times -4 over -4 minus 1 plus -4 minus 5 over -4 squared minus 1 equals 1. Then if I simplify that, I end up with -8 over -5 plus -9 over 15 equals 1, which if you were to keep simplifying that and get common denominators, I'll save you all of the steps. If you want to see it, go ahead and ask me. This would be 24 over 15 minus 9 over 15 equals 1, and that's 15 over 15, which is 1, so it works. But we have to still check the other one. So m equals 1. Just because one answer works does not mean they both will. So when we plug in 1, we have 2 times 1 over 1 minus 1. I already see an issue, but I'm going to finish writing this out. Plus 1 minus 5 over 1 squared minus 1 equals 1. I see my problem right away. Both of these will equal 0. So this is not a possible answer. M minus 1 or m equals 1 does not work. So only one answer works. So even though we got 2 that looked like they worked and looked like they were our answers, m equals 1 was the extraneous solution and does not actually work when we plug it back in. That's why it is so incredibly important to check for your extraneous solutions, because sometimes you'll get lucky with the last example and they both work, but sometimes you don't get lucky and they do not both work. All right, that is the end of our notes. Have a good rest of your day.